In this example, I'm going to discuss the concept of lag between the dependent variable and the independent variable for the purpose of forecasting. And the idea is sometimes the independent variable, the predictor variable, may have an impact after a time lag. For example, interest rate, mortgage interest rate, and housing starts. So when market interest rate goes down, for example, or goes up, either way, the impact will not be in the same time period. So like, for example, in the month of January, if the mortgage interest rate goes down, maybe the effect of it will be felt in February or maybe even in March. There may be a lag between a change in the predictor variable X and the independent variable Y. So in such a case, and we want to figure out how many lags is appropriate. And one of the things that we can do to check that is the R squared. So here in this example, we have an independent variable Y, which is the price of unleaded gasoline. And the independent variable, the predictor variable, is the price of crude oil. Now we are expecting that there will be a time gap between a change in price in the crude oil and the time by which the effect of it will be reflected in the price of unleaded gas. So we have 24 months worth of data, and the price of gasoline and the crude oil are for the same month initially. So there is no lag at this point. So if you think that the crude oil price will have an immediate impact without any lag at all, then you don't have to make any changes to the data. You don't need to lag the data. So we can find the R squared value by simply taking the Y values and matching them up with the X values without any lag at all. Okay. Now that will give you the R squared value without lag. Now suppose if you think that there is a 1 month lag before the change in the price of crude oil will have an effect on the price of gasoline, then what we're saying is that the price of crude is not relating to the Y value in the same month, but there will be a lag like this. So you have to match, not this way, but this way, that crude price with this gasoline price, this crude price with this gasoline price, and so on. Okay, so at the end, it will be that price with this. So when you do a lag of 1, because you're going to lose 1 period worth of data, so which means your Y range is going to be this, and the X range is going to be that. So there will be a 1 month lag. So with 1 month lag, the R squared will be that as Y and this as X. So that gives us a 1 month lag, and you see that 1 month lag actually decreases the R squared value. Now suppose we want to try a 2 month lag, so which means the association is going to be this crude price will have to be matched with this unleaded price, and similarly the next one will have to be matched here, and so on, and the last one would be like that. So if you're going to use a lag of 2, you're going to lose 2 periods of data, and now the R squared value is going to be, okay, so you have to leave, for the Y column, you have to leave the first 2 periods off, and for the X column, you have to leave the last 2 periods off. Now that will give you the R squared value with lag of 2. And similarly, lag of 3 will be RSQ Now for the y values, you leave 3 periods off, and then for x column you leave the last 3 periods off, and that will then have an effect of lag of 3. So now when you compare the fit measures, you see that no lag is the best in this particular case.